Our next speaker, Nokia's own, based here in Wrocław, Remigiusz Michułka. Remigiusz started his IT journey as DevOps and network engineer over a decade ago, and then moved to designing and implementing various systems and solutions. Today he helps implement best practices in Nokia products and also 5G. Remigiusz sees himself both as an engineer and creator and keeps asking those questions how and why. He's a microservice evangelist and never shies away from any technology. His talk is called Practical Aspects of Microservice Architecture. A round of applause, please, for Remigiusz Michułka.
Thank you very much for this warm welcome. I'm here to talk about microservices. So let's focus about the microservice architecture today. I came here to pour my knowledge into your heads. Why and how? Because of this lecture, and especially why? Because I want you to learn from my experience, from my mistakes, so that you don't have to recreate the pain and lose as many hairs as I did when I had to learn this. So this is my face in color. If you haven't seen it, you can find me after the lecture so we can talk a bit more and more about more details regarding architecture. So the microservices evolution. This is something that you're all experts in. No? Okay, so imagine that at lunch you would like to use a fork and a knife separately to eat, or you would like to have some sort of Swiss knife with a fork, with a knife, with a toothbrush to use afterwards, and a brush to use it to clean the toilet. So, no, see, you're microservices experts. All it takes is a bit of common sense. Now, is it something new? Is it just a buzzword? Is it something that we all know? Yes, we do, and it already happened years ago because this is an evolution of practical needs. This is the latest, and my most favorite is the Unix philosophy that can be used to describe microservices today, and it's all about writing programs that do just one thing and do it well. And you also assume that these programs should cooperate together. This was composed back in the days when we had to build bigger and bigger operating systems like Unix, and programmers noticed that you cannot build just this one huge blob and expect it to work on every system. So they had to decouple, to split, but the programs, the applications still had to work together. And we know this, and this is something that we have as a given today. Microservices is just another evolution of what we already know. So keep that mindset. Now, what is the core of microservices? I would say it's loose coupling. And what is the loose coupling? The loose coupling is that you don't care what the other service, the other domain, the other party is having internally at their home. So that what you focus on only is the service of what the domain can provide, what's the data they return, and what they do for you. You don't look into behind the curtains. You don't care about that. All you care about is the service. So as far as I see, the service that provides me the things I need, there can be dragons behind the curtain. I don't care. To go through these presentations, I will use a very simple yet non-trivial application example. So we will decompose this application that we can use to order food to our fridge through a simple system and web UI. And I decomposed this into order, fridge, and food, which are simple domains providing different services that we require, and they're stored the data. They are owners of their data. The databases are not shared, so it's isolated. All the communication goes through interface. So what we can do is we can check the food details, we can check the fridge details and its contents, and we can order the food through a separate service that's called the order. When the service finishes the processing the order, you will get the notification about the food is being ordered. And this way, fridge knows that it should update its content. As a side effect, you will get email order summary on your email stating what you just did. This can be written in one way or another. So we can have this separately like we did in here, or we can have this ordering capability in the fridge so that our service called fridge provides a nice way to order items. What's the difference? In here, we need to focus on ordering food to the fridge to this separate order domain, and it has to have a knowledge about the fridge. On the other slide, we can see that the ordering is done through the fridge, and all that business logic is there, and the order is in fact just generic system that orders an item. It doesn't know anything about ordering a food. It's just a simple generic. So these are simple microservices that we have. So we decompose this one monolith that we had into separate services with separate deployment. Keep that mindset that these are services that are separately deployed, it's still a one big system that we need to look at from the big picture. The core of the system is the contract. Because we have so many services and we have so many interactions, we need to have the contract on the paper. What it means that the contract between the services is in fact a third party. So it's a separate artifact. So it's something that we can have even without the service implemented. This is something we compose and we described. What are the interactions, what are the functionalities, what is in and out from the service, and this is a separate artifact and separate document that we need to focus on. Why? Because everything is distributed. We need to know the relations and we need to design those relations. You will not always get it right, but you have to focus your effort on that. Now, let's go through system aspects, because while it's decomposed into small, separate elements, maintained probably by different teams, having different databases, different technology, it's still a system. So it's still an application that can serve as a black box to the client. So we need to look from a client point of view, and we need to look at this application as a system. So we need to analyze this way. So implement small things in your services, but think about the entire system architecture. The core and the most important thing that I find, and that saved me a lot of work and a lot of pain and a lot of hairs, is the feature introduction. The feature introduction means, how do I implement something in my system without breaking it? How do I control the inflow of features and changes in my system when it's distributed and everything can be separate without breaking it? So it's almost as just fueling a flying airplane, because you cannot just switch off the entire application or just swap one infrastructure with another as you would do with a monolith application. You need to think about this, and to think, you need to have a process. I know, more processes, more paperwork, but it's not about the process itself, but it's also about how you do it. It doesn't have to be complicated. It can be very simple. So this kind of a process is called blueprint. You can call it wherever you like, but I like the blueprint name. And it's a simple process that shows us what we need to do. So at the very top, we have feature scope, and we have business rationale. What does it mean? It's what we want to do and why we want to do something. Even the why is more important than what, because you might know what to do, but is there a real reason why we should do this? It will protect your system and your application from so-called nice-to-haves. I hope everyone knows this nice-to-have feature that client wants, that is hard to implement, but brings no real benefit to the system. So you will not be the first one and not be the last one. When I say that nice to have killed so many systems already, and just remember that to implement something that you have a business rationale for. Next, when you know why and what, you can look at the system as a black box. So you can have the system user story that will show you this big picture of what you want to implement and how it affects each domain and how it will impact your system's business capability. So what do you really want to do and how you want to do it in terms of your interactions. This will tell you if you have enough domains, if your composition is right, if you have enough services, and if your infrastructure is good enough and big enough to facilitate such scenario. When you do this, you need to decompose into services, so-called stories. The service can be the service that we had at the beginning, or it can be some piece of front-end that you need to implement as well. So when you decompose to the stories, you know how each service is being handled, how the interaction between services is happening, how the feature is implemented by each of the separate services. At this point, you will notice that services use something and they interact with each other, and there's interaction between services or front-end and service. And you need to write that down. This is very important that you understand this story and you know what's the result of this story on the service. As a result of this information, you will have API contract. So this third-party artifact that you will have as a document, documenting what you really want to do and how you want to do it in terms of interface. So it might be surprising for some of you that I want to have an interface representation before the implementation. So this is very vital that you realize how this will be on the paper, documented API, before you start implementing. At this point, you will have end-to-end tests. Yes, that's the moment that you jump in with TDD, and you will write tests so that you can verify the feature before even implementing the first line of code. This way, you will know and guard your feature. You will know that what you wanted to implement is implemented. Then you can proceed with internal changes. When everything is approved, you can proceed with internal changes, and you can start looking for technology at this point. So our API contract is the result of our API contract is the result of our business decisions, not as a result of the chosen technology. But beware, there are certain things that you need to look at. Building distributed monolith. What does it mean? That means that I have decoupled everything that I needed. I have so many services, but they are so coupled together that instead of having a nice microservices architecture, you just replace the class interface in your given language with JSON over HTTP or any other interface that you will choose. So beware of that. If something is closely coupled together, maybe it should be a single domain. Think about that as well. Don't have features that are too big. So don't have everything in one blueprint. Try to separate on a same level, to separate features and separate items so that you don't have too many system scenarios in a feature. Beware and be aware that API contract is the result of business decision and business design, not your implementation. So you might love your framework, you might love your language very much, but don't start with the technology and the team, start with the business decisions. This can be a compromise as well, because you might hire some new people, get the new technology, but still focus on the contract and focus on the business. Store this document, store the blueprint, have it linked and have it reused. Now let's focus a bit more on the interface, because there's a bit more to that than it seems. I already mentioned that it's a document, but how to write a proper document? What are the ways to define these documents? you can use it. You can use many approaches. You can use it in many ways, but there are certain things that you have to have in your document. One is the composition of your so-called story, however you will describe it, that you want to get the fridge details, and then you need to have the interface operation, so that it's in fact an interface operation in the given interface that you will choose, given form of this interface, so that it can be it can be learned and it can be understood by machines when they read this document, not only humans. So it's not only Word or PDF document, it has to be machine-to-machine document. This way, like for our example, we have get on some URL, we have post to create order for the food, and we can also send an email through the post to the proper URL. And we also have something that's a bit additional. We have events. So it's not HTTP or REST API related, but we have events. And those events can be in different form, documented in different other documents, like some event schemas as well. So it's up to you what you will use, but first have the action and approve the action name and the URLs, and also have the resource schema. So it's the form of how your in and out will look like. This way you will immediately see what are the properties of your object that is being sent, or the data that's being sent. At the very end of your document, you need to have the dependencies. So you need to have some sort of links that you are using, and you're sending references to different objects through your API. Like to order a food through the order component service, we need to provide a reference to the fridge and a reference to the food item, so that it can be compiled together in the order. So that kind of dependencies needs to be written down and guarded. So what's the form that you could choose? One of the forms that I personally very like is the Swagger. Who knows anything about the Swagger and Open API specifications? Yeah, I don't see too much through the lights, but I can see some hands in the air, especially my team. So I'm very glad that you know about Swagger, because it's becoming more and more popular. And what are the benefits of the Swagger? And what is the Swagger for those that do not know? It's the API documentation in YAML and JSON, or JSON. It doesn't matter. But it's a way you describe your API through set of rules, so that it's well-defined and understood. What are the benefits of having this sort of documentation in Swagger? Well, the entire ecosystem. It's not just the specification language. It's an entire base of system software applications that can help you. Help you how? Like to introduce left shift practices. Left shift means testing as early as possible, and this means that you can start writing server mocks and generating functional tests just based on the artifact, based on the API documentation. So you can write the entire front end, the entire client application, without implementing any of the server side, of the backend side. This is very beneficial when it comes to separating the workload. So other things are like common code changes can be implemented, so that you don't have to write everything from the scratch. You can generate some of the client code based on the Swagger. The Swagger generator provides a variety of languages that it can generate those, so it's not a problem. You can even generate with a limited pool of server mocks, server schemas, so that you don't have to write down something you see on a different piece of paper and do human mistakes. You can just have it generated. So it enforces a focus on a business representation. And this business representation is also on the paper. So I don't know how many of you are programmers, developers, but I assume most. You know that feeling when someone is just describing something to you, how the class, the function will work, and you say, hey, okay, but only when you see it in the code, on the paper, you know that something is fishy, that maybe with words it sounds nice, but when you look at the code, you see that, I would do it in a different way, or maybe it's not clear, maybe the business, it's not okay. This is the same with Swagger. That's why I advise you to write this down on the paper. When you have enough experience with that, there's one look at the Swagger and you know that something is wrong. It's the same as having having a code, and you can look at someone's monitor from very far away, and when you see a code going like this, you know that something is wrong, even without knowing the language. So that kind of composition and that kind of elements will help you, especially the Swagger. So serious part of microservices that you need to be aware of is the split responsibility, because you might have amazing interface and you might have everything well documented, but if you design the system wrong, then you will pay the price. Well, people, maybe even people after you. So let's look at the two examples we had at the very beginning. So on the left side is the system where we have a fridge using generic order interface, and on the right side we have this first implementation when we have order and the fridge on the same level. So the client is using the fridge and the order. So now imagine, you can see what are the dependencies. You can see that something depends from something, something is using something. But now imagine that on the left side, the order interface needs to be broken. What does it mean for your infrastructure? How your blueprint would look like? You would have to change the fridge. I mean, you don't have to, but imagine that you have to, because the interface is broken, and not because of someone just having a change, but because it's business related. So it's business impact that you need to break this interface. So what do you have to do? You have to update all the interfaces that are using, services that are using the order. So now you have just one fridge, but multiply that by 100. You've seen the decomposition. You've seen how it can grow. So not all the classes, but all the domains can grow and grow and grow. And then you will have this one dependency because you created this way with this one domain, and you will have to affect all of those services. That's quite a lot of work. While on the other hand, I'm not saying it's any better, but from this scenario, when the order interface changes and we have a separate order domain for the fridge, or the URL for the fridge, then that's just the fridge features that are affected. This way, we can mitigate the effort. So think about how you split your system, not only how you design, but how you split, because it might impact you in the future. So my advice is design for the worst. So design so that anything can change, anything can be broken. Play these scenarios in your head. These scenarios, like alternative scenarios, can be part of your blueprint design. So have that thought process during your designing process as well. Now let's go to the testing. Who's testing their code? So who's testing? Everyone? Oh, I don't see the entire hall. All right. Okay, so everyone are doing the testing, right? Who's testing? Who's doing testing as a continuous part of their development? So for me, developing means testing mostly. So verifying the code. And to do that efficiently with microservices, you need to automate. And I don't mean automated tests. I mean the automated pipeline. So the entire circle that you might know from any other sources, and because it's similar, it has to be automated. And I don't mean that someone will just trigger something. It has to be from the moment you press merge on or approve a change, then it will go and be deployed on the production. There are companies that prod or shift to production, so publish to production every 10 seconds in their microservices infra. So have that scale. Have that scale in your mind when you automate everything. So not only the design blueprint is the initial element. So for us, the automated part would be to having a Swagger. And then you can implement the feature. And when you press the merge, you can validate the feature. So your pipeline is helping you when you develop, when you design and when you have to validate the feature. So each service needs to be validated separately at this point. Then you need to integrate all those services that you have and see if they work. Not only in some separate infrastructure, but probably also in a pre-production environment which is close to production. So think about the scale. Think about how your monolith application would be tested and how it has to be done with microservices. It's another cost. It's an additional cost, but there are also benefits because you put in a thought process into how your pipeline, your developing pipeline, it will look like. Then you need to deploy. And it's not about just restarting one application, like pushing code and restarting the application without any downtime. It's about injecting just one service out of many, and they still need to work. So deploying a breaking change with microservices is very easy. You just add it, you add it to the service registry, and it's visible and can be used. Even if there is no client, it's still there and can be used. But when you have non-breaking changes, so additional features that can be discovered and used, and client is expecting that every deployment, because you can deploy the same service many times, every deployment of the service is providing the same contract, even the additional non-breaking features. So that kind of deployment gets complicated, and you need to be aware of that. You need to automate that process. This means additional work. I encourage you to use gating, like Zul CI, they use in OpenStack, so that you define your pipeline end-to-end and all the dependencies and ins and outs in a way that's clear for everyone. So it's not a connection of many frameworks. I mean, but it might be a connection of many frameworks, but you will have this one view of what is happening with your pipeline. And you need to test. And about testing, it also gets complicated. So with your monolithic application, it might have been simple. So you have some UTs, some component functional tests, and then you can push to production. But with microservices, you first need to test the libraries. So then you have to shift the libraries to be used by services. The services needs to be tested separately, and with component and functional tests, these can be generated. And then you have a system. The system needs to be integrated together. Even the services that are not being changed have to be retested because there might be dependency. So see, the dependency part in your interface, really helpful in that, so that you don't test everything, you don't bulk up everything on the stage, but just some bits that are affected. And then you have to test end-to-end. So if you change something in the backend, it would be nice to test also all the applications that are related. So this pipeline can take a while. Security. Yes. Who focuses on security in their companies? Or is it a separate field, or is it just a byproduct of what you have noticed during development? All right, that's an open question. So think about this, how you and your company focuses on the security. Why? Because with microservices, everything is a security issue. Why? This is just to show you what are the impacted areas that you need to focus on to have the wow effect. Why? Because when you had a monolithic application, the internals were somehow hidden from the client. So there was at least no clear and easy possibility to have a man-in-the-middle attack. But with microservice, everything is distributed. So in fact, you need to protect yourself from someone injecting a rogue service into your infrastructure. Well, this can happen. So why do I have to attack your front gateway, where there's authentication and everything is nice and heavily protected? I can just hire into your company, hack your Jenkins, Zul, or wherever you have, or GitLab, get an access there and push a service to production, a service that's not maintained by anyone. So think about that as well. We have a couple additional elements here, like authentication, key stores. Hey, you need to store your secrets somewhere, not hard code them. So this is also an important issue. So you need to have this, figure it out how you're going to do it. It's much more complicated than with a monolithic application. So be aware of how many areas are affected And we can split this into security layers with external gateway. So you protect your system from the outside. The API gateway will do the authentication. Even the cross-service communication will go through the API gateway. So we can have authentication authorization there. We can have service discovery so that only things that are in the service registry are published and can be used. And with this, we can also limit this API contract so that not everything that service offers is offered to the client or to other services. We also have to protect the event and queue elements. What does it mean? That when you emit some events, like we did with our order and fridge, these are results of some external interaction. So yes, you can verify the incoming request, but imagine that someone injects an event or a task into your pipeline, into your system. So is your service verifying that what's in the pipeline, in the queue, in the event pipeline, is it legit? And even if it's legit that this user can do this thing, is this order legit? Or maybe I've just injected something and I'm deleting all the data for a given user that never requested such a functionality. Think about that. This is also a very, very possible vector of attack. In the end, you also have to protect your data because we have services and these services have their data separately. These might be different databases, so they might require different protections. And this also means that there might be some level of encryption required. So do I encrypt the entire database or just a portion of it? Or do I encrypt for an entire system with a system key? Or maybe I will have a service key. Or maybe I will have some sort of user-based key because I don't want one user to have access to data of the other users, not only based on the authentication and authorization, but also based on the physical access. There's one thing with data that's very, very, very important. Don't have pre-production based on the dump of your user's data. It might be obvious for some, but remember, don't have pre-production based on the dump of your user data, because it only means that you have unencrypted data, or you're transferring the keys in the wrong place, or that you don't encrypt at all. So think about that. Many attacks happen because someone forgot this copied piece of data on some developer virtual machine, developer environment, and it's just sitting there, this couple gigabytes of user data that might surface in a couple of years. So think about that. We also need to focus on monitoring and audit. This is very important because everything is distributed. So when you had Monolith, everything was logged into one pipeline and then sent to some other place. Now you have so many components and they all generate logs. And they not only generate logs, but they also generate events. And you need to have KPIs for that. The KPIs and monitoring systems are not just for you to have a nice dashboard or maybe receive a text message when something goes wrong. It's about having actions based on the scenarios. So in your blueprint, you also need to focus on security because you will have to have scenarios that start when there's a security threat. And perform a risk analysis. Why? Because in risk analysis, you can have all those layers secure, but also assume that everything can fail. So we might have a protected system when all those elements are green and operating at full capacity. But imagine that there is a hole in your external gateway. How your system will be impacted? Or maybe some guy just removed the encryption in the databases or broke it from the beginning. So what will happen? Will your system will be affected? How the other elements will compensate for this issue? So if you have elements that are very, very important and they show you that there is a bus factor, with this. So when this one element is broken or removed, then your entire system is open for the attack. Then you need to include that in your risk analysis. I'm not saying that you should address all of those elements with full capacity, but you need to focus on your business, and you know how your business will look like and how it will work and how much of this you need to implement. This relates not only to the monolithic, but also to the microservice architecture. But think about that. With microservices, it's very, very important that you do that. So now let's focus on the entity aspects, meaning because our application is a system-wide, we still have some entities inside. And how we do those entities, what we implement those entities, it can affect our entire application. So just to catch up with all the core components that we had, a couple advices on those elements that we really need. So as I mentioned, the API gateway to protect us from the outside and to control the business interface. It's a control of what we show outside. Template your services, but I don't mean template as a template that you just copy-paste and you have another service, because this would mean cloning technology. Template approach. So have some process, have some development process, designing process to guide your new hires, new people in your team, how to do that correctly, so that most of your services are similar in terms of architecture approach. Also have the key store. Don't hard code secrets into your application. I know that you know that, but don't do that. So keep that in mind. You also need to have the deployment service, because deploying manually at midnight causes a lot of headache to everyone. And that's very important. So have this automated. Have this so that it's not prone to errors and it can be tested automatically before pushing to the production. So have all those scenarios thought out and played out into your system, so that you are not afraid to merge on Friday. Keep that in mind. You need to have, obviously, some authentication, authorization system, like OAuth. Think about that. Have the service discovery, which is also called service registry, so that you know what kind of services you have in your infrastructure. You need to be aware of that. It cannot be only a result of listing that you do on your system, but also it has to be a continuously updated database. You can also use that to store your interface description there. Also have the monitoring, as I mentioned, not just to have the dashboard, but also to have scenarios. So have the logs and events bound up in some system that you can view and you can analyze. And especially when you do have to audit. So what are the service patterns that I really like and that are really helpful? There's this one that I really love, and it's called circuit breaker. On the right side, it's not what you think it is. It's a diagram. So a circuit breaker is a really, really cool feature. How it works, it counts the errors that you generate from your service. So you have incoming requests to a feature, and you have some errors that are happening for whatever reasons. When the errors reach a certain point, the feature, the service, it might be entire service or just a feature of a service, is disabled, immediately disabled, so it's not even processed. Client that wants to request this URL, wants to send a request or do something, they will be rejected immediately. So no capacity, no way of doing this, we are having problems, go away, come back later. And the come back later is the clue. So you don't disable it entirely. You disable it for just a couple of minutes, some defined period of time, and then you switch it off, switch it on back again. So imagine that you don't have this feature and the order database is failing. It's getting really slow, overloaded, some infrastructure problem, something that we haven't predicted, or we invested enough, etc., etc. Or maybe the email service is failing and it's generating maximum timeouts in your system. So what will happen is that all the services that are requesting something from this service, or all the actions on the service, will bulk up because they will keep hanging, and you will have more and more requests that are taking more and more time to proceed before they are thrown away and the error is returned. This way, your resources will spike up, and in the end, it might be that your infrastructure will blow up. So with the circuit breaker enabled, your infrastructure will be, your feature will be disabled. So I'm not saying that it will fix your problem. The clients will still get the error, but at least your infrastructure will not blow up and it will oscillate on half of the capacity. So it might be that this problem is just temporary. The database is just failing for a couple of minutes every day. So I'm not saying it's nothing to worry about, but it will not cause the overload. And if you have some shared clusters, shared resources, like a single Kubernetes, then it means that it will not consume all of your resources, and the features that are not even related to the order or to the email can still function. So you will get half of the capacity, but it will work and it can self-heal. So the circuit breaker is part of self-healing. So it will not do and fix everything for you, but it will save your infrastructure. There are a couple more cool patterns that you can use. Some of them you've already seen in the design. They are called event patterns, and you can use events for certain things, like we've seen, the order communicates something to the fridge, so that the fridge doesn't have to wait for the request to complete, and the service just emits something. And this is a cool feature because the order doesn't know who's listening, and it doesn't care. We have a contract on the event, not on the interaction. So this is really cool because you can shout at the event pipeline and just do your business. You don't have to get a response that someone got this message. You can also use this capability to implement so-called event sourcing based on the command query separation. You can have a client. Imagine that a client wants to change something on the resource. And instead of just doing the database change directly, it will emit an event. And this event will go into pipeline and come back even to the same service, probably to the same service, just different instant, different process. And this process will do the change in the database. So you separate this, and what are the benefits? Let's have our simple diagram based on the simple application. So when when the order emits an event, the fridge will get it and do some business operations based on that event. And if a fridge wants to change this resource state, it will emit an event as well. And this event will come back to the fridge and it will change its database. So there are many benefits out of that. One, you do the separation. The other is that state changes are recorded in your streaming system so that you can roll back if you want to, and you have all the history. So things like history features or memento pattern, they are just for free, well, to some limited extent, and the retention period, but you can have that. And all those database changes, you don't have to generate separate, like for those that know Django, you don't have to generate separate signals that will trigger some form of archivization. You can just read the events in a different service, a service that's responsible having the history. So all those elements are for free. And it doesn't mean that you have an event-based system. It just means that for some business operations, you use the events to facilitate the business in a nice, resilient way. It's a bit useful when it comes to monitoring logs, so you don't have to create separate logs stating that you did something. You just focus on the event, so you can have the monitoring listening to those events as well and react. And this means that monitoring is not only a matter of security and stability, but also what's more important is the matter of business. So based on this, you can implement billing system, because you know how the states are being changed in your infrastructure. So you don't have to have a separate service with a separate interface, strict interface that is being called when something is being changed. You can just base that on events and possible rollbacks. So it's decoupled and it's free for you to change the business logic without much influence. I don't know how many of you work with great big infrastructures and billings, but I've heard and I've seen that billing is always the problem. So it always changes the most often, and it's the core of the business. to get the money for what you're doing. So it's very important that you implement it in a way that any interface changes will not affect the entirety of system. So it complicates a bit the transactions. So if you want to have transactional data and consistency, then you need to implement transactions manager. But for those that, for example, use Apache Kafka, there is a transaction manager implemented into that as well. So from a certain version, so you can use that and you can implement this to have a bit of transactional consistency for your events. Now, my most favorite, and something that many people know for those that use Python, Celery tasks. This is Saga Pattern. So it resolves about a couple simple use cases, which mean that we want to do something like these transactional changes of the state in a certain order. So it means that when we want to change in a way that we have consistency or we have couple endings on the resource based on what happens in the database, you can do this with Saga Pattern. So you can ensure that the consistent fallback, consistent change is being done with the Saga. You don't have to use events. So this is alternative. You can also use the asynchronous tasks, so that when you have a request incoming, you get a task instead of the outcome. So you can, so the service can perform changes and perform your task in a matter that it sees fits based on the performance, capability, wherever, and it can roll back or it can pause. So the execution can be delayed, but you still have the instance of the task that you can monitor. It can also be used to implement high-level scenarios, which means that there's this certain pattern that I didn't want to confuse you with too much. It's called aggregator component, which means that you have this bigger component, bigger service that provides, for example, some sort of backend assisted rendering of a frontend. So some business features that could be developed in frontend are developed in the backend, so that it's done in a different way. So like, for example, you have hundreds of infrastructures that you need to contact. So instead of having this on the front end, you can have this in the backend as asynchronous tasks, and this component will talk to all of those elements for you. So this is how it looks like in our simple application. We have a queue, so when we accept the order food, we return a task ID with a reference to it. You get a task which is put into the queue, and there's this separate task worker. So it's still deployed with the order service. It's not a separate service or domain. It's just a component inside that service. So it has to be deployed together because the tasks are the code, and they should be versioned as well. So you need to have that, but you can decouple the processing on the request interface, this interface that you accept requests on, to this background. So you can scale those separately. You might have this one process that accepts the services and hundreds of task workers. And it doesn't matter because you can scale them separately. So you can also adjust that dynamically based on the amount of orders. So this is the deployment scenario that I talked about. So you have certain steps. You send email order summary, and then we get an email. So beware of this pattern because it's very useful, but it's very easy to create a monstrous task that will just do everything. Like it will have a lot of chains, a lot of smaller stories inside, correlation, logic, and it will just be everything in one place and everything in one task. Have a look at that. If you design this in such a way and implement such a way, it might mean that you have one domain that's just too big, and maybe some pieces of this task should be in a separate domain or separate subdomain, because it's not only about having one box as a domain. You might have different services that can be subdomains. So this can be decomposed. To summarize, what I want you to remember from this great presentation, I hope, is that the pyramid of healthy microservice. So contrary to what some might think, We don't focus on the technology first. We focus on the design and the interface. So design your interface and have your business defined in a form of interface. Then invest most of your time in this, and then reuse the patterns that you have on architectural level to meet your requirements. To meet your requirements, your business requirements, not your technology requirements, but to meet what you want to do and why you want to do it. Design, reuse, and then at the very top, you need to choose technology and the team to meet your business goals. And that's the healthy pyramid that I propose. And this is what I would like you to remember from this presentation. Design the interface. Okay. And thank you.
Thank you. So any questions are most welcome, please. Feel free to join us here downstairs. Pyramids, food, fridges, orders, anything you'd like to ask about. Floor is yours. Would you like to join us here, please? Thank you. And then anybody, if you're interested, you can be next.
Hello. I will provide some scenario and then ask question.
All right.
So let's imagine the situation. We have a huge amount of invoices.
A bit closer.
Huge amount of invoices, huge amount of customers, and among many other tasks we want to do, one of them is like find all the invoices from all customers which are from this particular city. So doing this old way, we have database, we join tables, and we can do this pretty effectively. And now we have microservices. We have service for customers, service for invoices, and we don't want to have extra microservice to do this extra task. On the other hand, we don't want to send such amount of data between microservices.
Yeah, I see that.
And here's the question: what to do?
Yeah, what to do. So the question is that they had a monolith which contained data about invoices and orders, clients. I'm sorry. So about invoices and clients, and they wanted to filter out the two pools of data. So they split this into microservices. So they have resources for the invoices, resources for the clients or orders. It doesn't matter at this point. They have these two services, and they have interface. So I assume that very top they have some sort of business representation of the connections, and they want to filter that out. And do they need a separate component? So it might be that, and how to do it efficiently, because when you separate big pools of data, you need to remember that you decouple the interfaces, but you also split them on performance level. So it means that when you correlated something as a big model in your database, it was quick and easy to fetch all the data and correlate this data on the database level. But when you split that into two elements, then it's get more and more complicated because you have additional protocols, like you have to transfer all the data through the JSON. So what I would advise to do is to define and have a look at your domains, whether this can be one domain, whether this can be connected into one not monolith, but maybe a domain that it will result with business implementation in one of the services. So what are the relations between the data? What can you filter at? What can you cache? And maybe it will turn out that you will have some sort of aggregator that will fetch the data and fetch the references and do nice filtering on that. Or maybe you'll have state changes to speed this up. So it's not so easy to answer whether you should have implementation in this service or the other, or have something else. Because have you seen on the slide, you might have different approaches, and what you need to do to decide is to have a closer look at your elements. But it's a nice problem that you have, and if you want, we can talk outside and discuss this in more detail, because it's really about what are the invoices relations to the clients and where you would like to have the business of correlating the data. More question?
Yes, I have a question. Question about use the interfaces between the services that you have, and whether mixing the styles of interfaces and having is it better to to stick to one type of interface? For example, all services are triggered via request and response communication, or maybe have all the services respond only to events that are happening in the system, so like this pure event sourcing or pure synchronous communication, or maybe it's fine to mix and match the way the different services are triggered to do their work, some of them being triggered by a specific request to them, some of them being triggered by just an event that happens somewhere in the system.
Okay, so to simplify, the question is whether we should stick to one type of interface, whether we should have not only type, but I assume that it can also be a type, but in a way it operates. So whether we have this order, this request incoming, that request is being done, and then the data of that's a result is being returned, or we have just tasks or just events, and the answer is do a mixing. And that's what I mentioned also during the presentation. It's not either this or that. You have to analyze your business, whether this getting information because it can be cached. Maybe it's better to have request and request response, and maybe for some other task like generating some sort of a report, it's better to have this as a task that's asynchronous. So a task is returned and you can monitor the operation. My general rule is something I included in the presentation as well. Anything that takes more than 1 second to process at this current moment should be asynchronous task. So this is my advice, that if it takes a while, have it as an asynchronous task to gather the data. So it would also be the case for the invoices and customers and orders, because you would have to have this correlation of data happening in the background. You cannot let your customers hang out on the connection. So it's a mixing. So you need to analyze each of the features and decide whether you want to have this way or another way. Do not have either black or white.
And we've got several minutes for one more question, please.
This will be probably a fast one, because you partially answered this my question a second ago. But imagining a system consisting many services, and they are communicating each other, there's a need to implement the communication between the services itself. During the presentation, you mentioned some event managers, if I remember correctly.
Transaction managers as well, but yeah. So okay.
Because my question is, having a mix of different ways of communications may lead to the situation that each of our microservice needs to implement several ways of only communicating to other services, like communicating with one service through the REST API, with other through the RPC calls or something like this. It leads to chaos. So is there a way to avoid it?
Well, there is a way to avoid it on architectural level. So the question is whether it's also about the type that I mentioned. So whether you want to have just REST interface, REST APIs, or WebSocket APIs, or so popular recently gRPC based on protobuf. So or events like event bus like Kafka, or maybe Celery, but that's not true service communication. But so the question is how to avoid having 4 types of interface. So 4 types of client implementation in a given service, because this service has to communicate with so many. So my advice is yes, it can be avoided, but it's a matter of having your business analyzed. So whether do I need to have so many interfaces? What they are bringing to my system, and not only do I really need to communicate these services directly. Maybe I can fetch this data in a way. Maybe I can react to this data. So that kind of situations is usually a case where you had different teams liking different technologies. So at this very top, where you discuss how your business, how your interface needs to be represented, this is the place where you decide. So if you start with the technology, then you might lock on one team on gRPC, the other on the rest. So I'm not saying that it will be perfect, but when you analyze from the business perspective, from the interface perspective, then it can be avoided. But yeah.
Thank you. Thank you very much for all the questions. And this was Nokia's own Remigiusz Michułka.